So in the model, you may find the lecture book. So in the end of the model platform, there will be a lecture materials file. It's a PDF file. Here, lecture materials. It's PDF file with the materials from the lecture, actually, and it's better to read a little bit information from this PDF book. I will show it one more time here. So if you didn't see it before, method of processing, here you will find general information about medical diagnostics, methods of pattern recognition and meaning distance classifier, which we will discuss today. Feature linear discriminant function technique, also it's our today theme. PCA, and also about perceptron argument. We will discuss the perceptron later, and some kind of examples. We will not work with the statistical decision theory, I mean bias classification, because it's a little bit out of our main way. But you may also So please read this book, especially part with pattern recognition model. It will be a little bit difficult to understand sometimes because it's based on mathematical definitions, and also about PCA. I will find it somewhere. PCA, you will find some intersection between materials here and materials inside your guidelines, but it's okay. They are the same for the most part. So here you will see mathematical explanation. An example of the PCA. Okay, so during when you will prepare in preparation for the next test, you may use this book. So it will be better than presentations materials. Here are the book lecture materials. And also I've added records of linear regression task explanation. Here you'll see the page with videos from previous lessons. The first one contains generation of the model dataset. It's the first part of the task. And the second one contains theory about linear regression and the second step of the practice. But note that I forgot to turn on the demonstration of the screen in this second video, and you will see the code at the end of the video. You may just find the screen with the code and repeat it by your own if you need it. So we have approximately 1 month to finish everything, and I remind you that you have to prepare and defend 7 lab works. Today, during our plan, we need to start doing the 5th lab work after the lecture. So after the lecture, you will do the 5th lab work. Yeah? And we have to read. No, you not. They are. So please don't forget to perform lab works using guidelines. And also you have to prepare practical tasks about linear regression and also course project. Information about the course project and practical tasks you may find also in the Moodle. Here the course project, block, task and variants. Also practice linear regression task. Okay, and next, actually, we will have test number 2. When it will be? It will be approximately 16 of December. December 16. It will be about classifiers using LDA and minimum distance. It will be about non-parametric methods of classification. It's perceptron algorithm, and also it will be a little bit about linear regression also. So it will be quite difficult test maybe for you. And we will do defenses also. So actually we have 2 weeks to finish the main part. And also don't forget that we need to doing practical tasks for next week and some part of the course projects to do better, because we may discuss and I will give you feedback about your results to be sure that you are doing everything. Okay. As for the students abroad, we will continue with you today after the lecture, so please stay tuned, and we will discuss your results on lab works. And also, as I see, not all of you passed the test, and it's a problem because I don't have results for 3 students. Actually, only 5 of you from the group did the test. So from students who are connected via Zoom, Cap2 passed the test, but Jean Damitian did not pass the test. So could you say some words why did you forgot to do the test in real? Jean? Do you hear me or not? Oh, you may write to the chat. I think no. So somewhere here, but not here. It's not good, but Cap2 will be with you. I know that you are here. So today we will start our lecture about methods of pattern recognition. And the first method will be minimum distance classifier. I will try to find, I will check, do we have the record from the previous year? Because as I remember, I had records. So I must send it. I may send it to the Moodle. I see lecture about perceptron algorithm and type of errors, but I don't see the minimum distance classifier. Yeah. Unfortunately, there is no record from the previous year, but it will be a record from this year. Okay. Where's your notebooks? Take it. Don't forget that if you don't write something, it means that you will not remember what it was today. Okay. Let's start with the applications of the pattern recognition. Of course, in our case, we will work in general, and in major part, it will be some diagnostics of diseases. For example, you need to help the doctor to help estimate some range of the diseases using symptoms. yes, or laboratory tests results, or any results of treatment, for example, drug therapy, and all information about the patient. So the second important application is recognition and prediction of life-threatening states of patient, physiological states of man using a complex of electrophysiological indices. For example, when you want to predict heart attack using electrocardiographic signal, you may create variable system for long-term monitoring. For example, grandmothers and fathers, why not? When you may control the heart's activity at some distance, and if your system will assume that your patient has a heart attack, it may call to the emergency, and it's a really good application of the system. There are a lot of problems with this type of the devices, because this device should be really accurate and has high specificity, because false positive results costs a lot when you call to emergency without real situation. So it's a problem. The third application is automatic analysis and interpretation of biomedical signals and images. What does it mean, automatic analysis? As you remember, when we talked about ECG signal analysis, you remember that doctor needs to detect points on the ECG signal. Waves, lengths, wave period of the lengths of the waves, amplitude of the waves on the ECG. So do it manually is quite difficult when you have a record more than 5 minutes. So automatic analysis do it instead of the doctor and prepare results of these analysis on the computer. So it's really wide area of the researches, and it doesn't matter that we have these technologies more than 20 or 30 years, but it's still exists, and we will work with them more than 20 years in the future, I'm sure. But there are a lot of noise in the signals, and noise is the main problem for such systems. Also, part recognition is used in computer vision, speech recognition, for example, systems which allows to manipulate, to work with some interfaces using eyes movements. When you track their eye positions for patients with motion disorders, for example, yes, and they may do some manipulation. They may press some buttons using eyes actually to shift their mouse. Voice recognition, fingerprint, face and eyes recognition, handwriting and typewriting recognition, topographic maps reading, and others. Also, interesting application of the voice of the text recognition when the doctor has a patient. It takes a lot of time to print something. There are some systems which allows to record speech of the doctor, to just say something during declaration, for example, I'm doing this, this, and that. And the system recognizes the words and just print it into the report about the patient. So it's also interesting application in Finland, for example. After operation, you may ask for a full process of the operation when the doctor is saying everything, and speech recognizer does save all words in the right places. It's also understanding propagation. And this slide you just to remind you about our chain of processes. We will in our class we will discuss actually signal analysis of the results of signal analysis. So, and the source of our information will be some electrophysiological signal. In this case, you may see that we have some signal acquisition system from the brain and analyze the activity of the nerves and try to control the prosthesis, yes, to perform the feedback loop. Yes, in this part we need to extract features and after that do some pattern recognition. So we will work with this part of the chain. There are a lot of pattern recognition methods. Let's go to classification. There will be 4 ways to separate them. The first rule is in terms of object description methods. The one of them is to represent our objects using vector description in multidimensional feature space. And the pattern recognition problem consists in finding of the divided surfaces. Here, yes. But vector is not the one way to represent the object. It may be logical or syntactic description of the objects. So here the problem consists in construction of recognition automata. Maybe you're familiar with finished state machine, probabilistic automata, Markov chains, Moore and Mill automatas. So okay, there are some applications that allow you to construct automata which solve your problem. And there are some methods that based on artificial intelligence concepts. It's like everything that does not correspond to the first and the second part. When you are working with the information from different sources, it may be voice, text, images. For example, you need to construct a system which analyzes information from all sources. For example, Yandex company developed a cat boost algorithm based on decision trees, as I remember, which works with several sources to perform better quality of searching and recommendation systems. In Yandex Music, for example, they are using not only one source, several of them are combined into one system. The second group, second rule, in terms of classes intersection degree. There are 2 types of pattern recognition methods. Deterministic, when classes do not intersect. So we have 2 separated classes, and object may belongs only to one class. And the second one is probabilistic or statistical methods, when our classes may be intersected and object may belong to several classes with several probabilities. And actually, we may also add to this classification fuzzy logic. Fuzzy logic methods allows you to develop systems which may work in the case of warm water, for example. Yes, when you want to create something with not strong rules. If this value, if the temperature of the water greater than 45, it means that the water is warm. Yes, it's strange because 34 is also warm water. But in fuzzy logic, you may create a function which describe it's not probability, but the level of belongingness to one classes. That this water belongs to the warm water class with this function 0.8. So you have these functions, and actually there are a lot of in real world, there are a lot of machines which climate control, for example, to get warmer or colder in terms of this human sensitive explanation. So it's physiological. Let me just check it somewhere. And also in terms of the type of separating functions for vector description, we will divide methods into linear when our separation surface is linear or something. But yes, despite linear, non-linear, for example, quadratical separation surface, or logical. Also about logistic regression. In terms of recognition learning procedure, methods of learning with the teacher or with no teacher. Methods with the teacher suppose that we have known labels of the class. For example, we have 100 patients with diabetes, 100 patients without diabetes, and we know that this patient number 45, 45 again, but this patient belongs to the class diabetes. But when we have learning with no teacher or self-learning methods, we just have 200 patients, some of them, and we don't know groups, and we want to divide them into similar clusters. It will be cluster analysis. Also, we may divide methods into parametric or non-parametric learning methods. We will talk about non-parametric methods later, and we will explain also the difference between these two groups. In parametric methods, you work with something that's based on mean value, standard deviation, or another statistical parameters. So you estimate the parameters of your distribution. But in non-parametric methods, you don't estimate all of this stuff. You just work using another approaches. You don't know mean value. You don't need to calculate mean value. It will be useful when the shape of the distribution is not normal and you could not calculate something that represents your distribution. Yes, because mean value and standard deviation represent your distribution when your distribution is normal. In case when you have binomial distribution, these values will be not useful. Yes. And also, the second group is adaptive and non-adaptive learning methods. In adaptive approach, you may change some coefficients or some parameters during the learning, but in non-adaptive, your selected parameters should be stable. So, and this part will be, we will work with method which use vector representation of the objects. It's deterministic methods, linear methods, and method with the teacher, parametric and adaptive. So we will just select this. And we will start with the formulation of the object in multidimensional feature space. One more time, don't sleep. Be strong. Write it somewhere, right? write their materials. So in our case, omega will be classes. We have m classes and n features. So we have n-dimensional feature space. Objects will be expressed as a vector of features, x1, x2, and so on, till the end. Vector of features in n-dimensional feature space. For example, we may have such a feature as heart rate, respiratory rate, and blood pressure. For example, systolic blood pressure. And the class and the vector or our object patient will have these three features. So feature is a characteristic of the object, which is meaningful for our analysis. And let's suppose that we will have two classes, omega 1 and omega 2. In this plot, you may see visualization of the three-dimensional feature space. Here, x is a vector of the object, which corresponds to some points. And we may see two classes, two groups, 1 and 2. And we see that this misclassification of the squared object is clear. So thereby, the classifier of objects is a device that maps the points from Euclidean n-dimensional feature space into a set of classes. Just please write it somewhere, it's important to be sure that you understand what is classification and classifier, what is it? It's a device or operation or function device in general, because you may do it also as hardware. So classifier maps the points into a set of classes. So here you have some black box which take into the inputs several number of features, some object vector, do something with this information. In general, it will some function which depends on these input arguments and returns the class number. Let's suppose we have n-dimensional feature space and three classes. And any point of the plane subject to is belonging to domain R1 and 2 and R3 is mapped into one of the classes, omega 1, omega 2, omega 3. So we divide all space on the plane into three regions. And if the points lies in the R3, for example, it means that we will map this point in the class number 3. All these regions you may see here described by some complicated edges, but in real world it will be quite simpler. But here we may assume that this is a real situation for space. All three domains are separated from one another by surfaces. In this case, it's curves called in our study the separating surfaces. So this is the surfaces which separate two areas on the plane or surface with different classes. And separated surface of the classifier can be completely defined by m is equal to number of classes. Don't forget it. scalar functions. We will call it D function or discriminant functions. So to choose how to choose these functions, yes. For all objects from pyramid, see that it's region, so region where all elements belongs to the class I. The following condition was done. Discriminant function from the object from this class should be greater than for all discriminant function for this object from other classes. It's a rule. How do you describe it? Not now. Discriminant function is some function that should have this property. Yes. This is the properties of this discriminant function. Discriminant functions, how to find it, it's a second step. Then the surface separating of area adjacent areas I and G is determined by the following equation. Difference between two classes, two discriminant function for classes should be equal to 0, or they should be equal. But when you have adjacent areas, so you have the line which belongs to two classes, they should be equal in this line. Discriminant function should be equal. It's like a distance. Yes. For example, when you have this intersection between like the distance will be equal for this line, which lies between two points. They should be the same, so they will be equal for two classes. Because when your element lies in this, when your object lies in this line, directly on this line, it belongs to in the same way to the first and the second classes, for example. Yes, you could not solve to which class it belongs. So 3 discriminant functions and corresponding decision areas originated by them on the plane x1 and x2 are shown here. Let's look. What do we have? This is an example. So in the previous, we decided we have here we have 3 classes. It's not about 3 classes. Let's suppose we have 3 classes and 2 features. It will be our discriminant function x. It will be a plane, and if we transpose in the project it into features, you will see that actually it's areas on the plane. But if you put the point here somewhere, let's something like this. Let's suppose you have an object in this region, this object on the plane. To find the class, you need to find the discriminant function. Yes, and the discriminant function will be higher for the third one, for this 3, because it goes somewhere here. Yes, and also if you select the object from this, you may find the value of the discriminant function to be somewhere here. It will be the highest value of the discriminant function because you don't have this value this object is free, yes, because V3 will be higher than the other than V1 because we know up here. So it's like we have 3 objects. Here we have 3 classes. 1, 2, 3. There is no objects. What objects? Yeah. It doesn't matter how many objects you have. Actually, several objects. I might draw all of them here. 2 features. So n is equal to 2 here, and m number of classes is equal to 3. It's like the visualization of the discriminant functions. So introduction.
Like the object y considered as an item for the group 3. Why it's not for the group
2? One more time.
The item, the object.
This one.
Yeah. Yeah. Why would we consider it as an item for group 3?
Because seconds goes lower. Intersection between this projection of this object to D2 will be somewhere.
Yeah, exactly. The same distance from.
Yes, but the value will be minus.
Like that condition, right? Like that condition with
I know this object and no, it's the same. If you got the plane like this and if you get the plane like this.
We couldn't know it actually. We may.
So maybe the group 2 here.
But for this, this 3 will be.
It's all about the distance from the item and the plane of the group.
Projection of the item into the instrument function. So we need to take into account the sign. Plus or minus. It should be minus something. So it will equal but minus something.
I think right now we cannot decide if it belongs to the or equal, but when we deal with numbers, I think there's more obvious.
Yes.
So it may be considered as an item for group 2.
So we may transform object classifier model to some block scheme. We have unit name discriminators. They calculate discriminant functions in accordance with the number of classes. And discriminant functions may be of different types: linear, equilinear, nonlinear, and quadratic, or something else. And solution of the pattern recognition task arises the problem of choosing the type of the discriminant function. So you have the input objects, calculate all discriminant function, find the maximum of them, and your output will be the maximum class for which the value of the discriminant function will be maximum. The simplest type are linear discriminant function. They may be defined by the equation here. This is the sum of the this production between coefficients, our features, weight vector, and some additional coefficient or free coefficient without the object. It's like a kx plus b in linear regression, b without any feature. Number of coefficients is equal to n plus 1. So if you have one dimensional feature space, you will have two coefficients. If you have 10-dimensional feature space, you will have 11 coefficients. And this discriminant function should be created for each class. So the number of discriminant functions is equal to class number. It's better to just to write it somewhere else. And here you may see the example for the first class linear discriminant function. And the first index corresponds to the class number. The second index corresponds to the feature number. It's a vector, weight vector actually. It's a weight. On coefficients, values, which you need to calculate during the training. When you see, when you build your classifier, you need to estimate the coefficients that you create a classifier. And in this case, surface separated into adjacent domains, I and G, may be derived as following. So it will be some line with coefficients. And here coefficients will be subtraction of the coefficients from the ice class and G class. It's just when you take this equation minus the same equation with G instead of I, you may change the subtraction of coefficients to some new coefficient with the without number of plus. And also you may use we will use the equation for discriminant function between two classes I and G. So fix your attention into this equation. This is a general equation. This is separation surface between two classes. So, and if number of classes is equal to 2, we have simple equation for linear plane, and by the sign of the new discriminant function, here we will have a sign. We can attribute the input object to one of two classes, 1 or 2. Yes. If discriminant function greater than 0, then we assume that we are in the region number 1, and the input object refers to class omega 1. In opposite case, when the discriminant function less than 0, then it corresponds to the class number 2. And the most popular form, also highlight this moment, the most popular form, and we will in our lab work will use this form, matrix form of the equation when discriminant function is equal to weight vector multiplied by x minus a is equal to 0. And here w, the weight vector of unit length. What does it mean, unit length? Do you know?
Let's say 1 meter or
Just one.
one, like one of something.
Yes, so the length of the weight vector is equal to 1. And here A, the threshold value. So the weight vector and threshold value is here. But I just also want to fix your attention that this form transposed weight vector multiplied by the object actually is not, it depends on the shape of your weights and objects. As you remember, we need to multiply row by column. So in this case, we have columns for vector, column for object. Yes, but in so we transpose the weight vector to have the row and multiply it by column vector object. But in the but most popular form in our case, we have objects in rows. As you remember, table, objects by rows, features by columns. So what does it mean? That we need to transpose also object. No, it's not clear. Okay. Why is somewhere here? As you remember, we need to multiply coefficient by feature, coefficient plus coefficient, and that's so on. Let's suppose we have a table. Rows. Yeah. So in our cases, we have 1, 2. So remember in your first project, for example. So we have features in columns, like object 1, object 2. And let's suppose we have weight vector in the row also. I don't know why, but this calculations in MATLAB gives us weight vector in the row. We want to multiply part. As you remember also, n plus 1 features or coefficients. So what should we do? Transform what? X. Transform. It does. It actually, we may
That's
just.
why I get confused. Because it's W is 1.
We may do what? We may take X and multiply it by the transport row by column vector. It will be the same that we did in our results. And it will be, but if you have vector in column and X contains objects here, it means that you need to transpose. So W will be huh? W will be here, yes. So we will have from here because we transpose here. You don't get it?
It's not about me getting it. It's not to communicate. The emphasis on like the multiplication of yeah, so you can.
Let's calculate.
Here, look, doctor, here in the W transpose multiple by X, yeah, you get matrix, a new matrix. Or and here you get only yeah, vector. Here you get only vector. Here you get a new matrix. Here you get a new matrix.
Here you have also vector.
Yeah.
Yes. Let's try. Suppose we have column vector 1, 2, 3. Let's suppose we have
Yeah, but we said that W. That's why I'm saying
but it's a vector. vector may be column or row. I've said that in original theory, we suppose that we have columns, but in real life, it depends on the program. We just to be sure that when you will write your own code, you will think what you're doing, how to obtain what do you need. Expression actually. What do you need to multiply what by what? Where it will be grow by
I
what?
was like just doing this on this.
Okay, so in your program, you may have this situation. If your weight vector will be a column, it means that you don't need to transpose it. So keep in mind the shape of the objects. Okay. So this case, when you have column and column. Let's suppose we have two classes. It means that we may use logic threshold units, which compare the discriminant function with 0 and returns 1 or 2 as the result of comparison. And also, don't forget that this projection is projection for direction, and it's a result of multiplication of the lengths of the vector to cosine of the angle. And you may visualize projection like this fall into the direction. Projection gives us value with the sign. So the direction of the vector is important because if you change this direction, you will have opposite results. And recognition procedure, pattern recognition, yes, recognition procedure consists in calculating the projection of vector x onto the direction of the weight vector w and comparing the value obtained with threshold a. So we project into some weight vector from discriminant function, it goes into weight vector and comparison of the projection to this weight vector to the threshold a. Separating hyperplane crosses this weight vector perpendicularly. I just highlighted, it's important. I will ask you about it in the defenses. Perpendicularly at a distance from the coordinate origin. So separation surface is perpendicular to the weight vector. It's important. Separation surface. I will show you it in the example. So when you divide your surface into two parts within the weight vector, this dividing will be perpendicular to the weight vector because you have some threshold. When you compare projection with threshold, you have actually two parts on the left and to the right of this threshold. And there are a lot of methods to determine the weight vector, and based both on the criteria of the statistical decision theory and on the maximization of somehow defined distance between classes. So we need to maximize distance between classes of projection, and we need to find this metric. For example, it's one of the approaches. So how to estimate this distance. In LDA, yes, we are smiling today. Why? So in the lecture materials, you will find an example. When you have 6 features of the EEG signal, it's a real example. For example, zero crossing rate, average amplitude of EEG signal, number of extremum, average amplitude of the first there. Also, I just want you to be sure that you will read this example, because it's important to understand the idea what could be a feature of the signal. Yes, what it could be in general. In this case, is a classifier for for anesthesia level to control awakeness of the patient during operation. To estimate do you need more anesthesia or not? A level of condition continue. Consciousness, yes.
When you need to make an operation,
you go to sleep and you need to control awakeness, because when you awake, it means that you need more anesthesia. Yes, to control this situation, depth of the anesthesia. Yes, you may use several approaches to do it. So in this case, you may construct system classifier.
the X's are features that already exist, or that are features that we get.
We need to extract from the signal. So you develop a system which extract features from the signal, and after that you construct a classifier which classify the for example, you calculate these features in each one per 10 seconds. You analyze 10 seconds chunks, and it means that you have classes for each 10 seconds. Here the example, when you have your input signal, ECG signal, you have some differentiator which returns the first derivative. You have the second differentiator which gives you the second derivative of the EEG signal. You have zero line crossing rate algorithm, and also envelope detector which calculates envelope. And you see this representation of the algorithm gives you clear understanding of the input and output data from your blocks. And it's really a good example how to visualize your algorithm when you will prepare the presentation of your paper, master paper, for example, or when you create some article to explain in simple visualization the structure of your algorithm. It's a good idea. Of course, all these blocks contains some function which takes as an input derivative and returns feature. Yes. Here I have weights actually, and calculate the here I think there is like a normalization of this, and it returns the number of the class, and not number of the class, the value. Compare this with the class. For comparator with thresholds, because in case of 2 classes you have 1 threshold. When you have more classes, you need more thresholds to divide to find the projection part. Yeah. And let's go to one of the simplest way to find the separation surface between classes. So the main idea of the discriminant of the discriminant function and the weight vector and threshold is clear. Yes. But how to define these vectors, this vector, how to calculate the coefficients for separation surface. The first algorithm which allows us to do it is a minimal distance classifier. We have m standard vectors, which m is number of classes. So we try to describe our class by the standard vector. We have n-dimensional character space, each of them being the standard of its class. Standard vector in n-dimensional space. And this vector corresponds to the class ith. Yes. The new distance classifier assigns the input vector x to the class I when the distance between this object and the standard vector will be minimal. So, sorry.